every couple of years I watch Gattaca, and every time I watch it, there is more in the movie that is just, that's how we do it.
Greetings, Earthlings, and welcome back to Earthlings 2.0, the show where we imagine how we can be better versions of ourselves and build a collective future we actually want to live in. On today's show, our guest is someone who tracks the developments of genetics and DNA sequencing and can shed some light on what we can expect in the future. You know, on this show, we talk a lot about climate change and challenges related to the energy transition, but there's a lot of other really cool futuristic stuff happening out there in the world. And today's guest is a delightful guide on what we can expect from genetic research. And we're going to talk about things like medicines designed specifically for your genome, or ethical gray areas around selecting certain types of embryos over others during an IVF process. But before we beam our guest up to our proverbial spaceship, I'm your host, Lisa Ann Pinkerton. I'm the CEO of the award-winning PR firm Technica Communications and founder of Women in Clean Tech and Sustainability. And before building those organizations, I was an award-winning environmental science reporter for NPR and PBS. And if you're new to the show, welcome. It's really good to have you here. Thank you for being a listener. And we hope that you like what you hear today. Feel free to have a look around, check out our back catalog. We have topics like autonomous vehicles, lab-grown meat, renewable fuels, and much more. If this is your second or 20th time listening, thank you for joining us each week and being a loyal listener. And to that end, if any of you feel so inclined, you are welcome to give back to this hardworking team here at Earthlings 2.0. That includes Jay, Stacia, Jenna, Olivia, and Herman. And you can do this by doing one of the following things. You can go to our show notes and take our listener survey, even if you're a first-time listener. Knowing some background around the type of person you are will be really helpful for us to understand who our audience is. And you can join our newsletter so that you can get other notifications around groupings of episodes that make sense to listen together and the latest drops of episodes when they happen. And you can also share your favorite episode with a friend. And if just 10 of you did one of these things each week, by the end of the summer, we would have expanded the audience for our podcast markedly, and we would have a lot more data on who you all are. So please consider going to our show notes and taking the survey and sharing the podcast with a friend. And thank you for Resource Labs for having us on the network. As I mentioned, our guest today is the host of a podcast and radio show called DNA Today. It's won multiple awards over the years for its exploration of how genetics impact our health. And each week, host Kira Dineen interviews leaders in genetics, including counselors, researchers, and patient advocates, to tease out what the latest developments are in genetic health and what those ethical questions are that we should be asking, and how to ensure that these benefits of genetics research are equitable for everyone who needs it, regardless of how much money they have or how affordable or effective the insurance system is where they live. Kira herself is a certified cytogenetic technologist, and we caught up with her from her home in Las Vegas.
I think what's so fascinating about genetics is how much we don't know, how much there is left to learn, and also just how much changes. When I was in high school 10 years ago, I remember asking a question of, well, what is this thing we're calling junk DNA? It must do something, right? And they're like, no, it doesn't do anything. Yeah, 10 years later, we don't call that junk DNA. It does do things. It's helping regulate other parts of genes. And I think that's a very thrilling aspect of having a career in genetics, having a podcast where I just nerd out about genetics with other people like me, and being able to dive into all that and how much we have left to learn. And even just from starting the show 12 years ago, of how much has changed in that 12 years. It's just really an exciting time to be in genetics.
Yeah, it is. And I appreciate you said that about the junk DNA, because I think it's so funny. I think we see the same thing with dark matter. It's like, Well, it's doing something. We just don't know yet why it's there.
Yeah, I think we even see that in neuro a lot too. Like, well, we don't understand how the brain works. It's that we don't understand yet. Like, there's so much left to unpack.
And your podcast, DNA Today, you cover a lot of different topics. And I'm curious to know, what do you think has been one of the most fascinating or unexpected discoveries that you encountered during your interviews?
I think a recent interview I've done was really impactful of just me as the host. So the premise is that there's this technology that we've developed from discovering something, and that's called CRISPR. And we discovered that CRISPR is a naturally occurring phenomenon kind of thing that bacteria have. It's basically kind of their immune system. And so we were able to discover this. There was this landmark paper in 2012, which was the year that I started the podcast, DNA Today. Fast forward to 2024, and we now have an FDA-approved treatment, I would venture to even say cure, for sickle cell disease using CRISPR, where we're basically editing someone's cells so that they are producing the quote-unquote correct normal red blood cells instead of the sickle shape. And because we're able to do that, I talked to the person that was the first person cured from a genetic condition, sickle cell, using CRISPR. And I'm just like, oh my God, like just that timeline of that 12 years of when I started the show.
And is that the CRISPR, that's what some people have called precision medicine, as sort of a field of medicine that's starting to develop based on genetic information and customizing a medical treatment specifically for an individual patient. Can you tell us a little bit more about how this precision medicine is really shaping healthcare?
And this is something that's been around. We're now shifting how we're able to do this. So personalized medicine or precision medicine, I do like the term precision medicine better, as you said. That could be as simple as someone needs glasses. So I don't know, do you use glasses or contacts or anything? Okay, most people do, right? So we both need that. Now, my prescription is probably different from yours. Like the negative number on my contacts that I put in every morning is probably different than yours. I'm negative 4.25 and negative 4 or something like that. I also have different between my eyes. They're different.
Right. And the shape of your eye is different.
That too, right?
Yeah.
Yeah. So all those factors, yes, there is, okay, you need glasses, you need contacts. But between that, even between the two of us, your numbers are probably different. And so that is precision medicine of personalizing it. Now, there's other people out there that probably have the same number as me. So it's not, and I think that's also why I prefer the term precision medicine instead of personalized, because you're creating a small group that you're like, okay, these specific people, this group of people needs this specific treatment. So yes, are there cases where we have certain companies developing drugs for one person? Yeah, it's amazing. And Lorem is a company that I work with, that I produce a podcast for them. And that's what they're doing. But in general, precision medicine, looking at like, okay, well, let's create a treatment that's really for a specific situation, for a specific disorder, for a specific symptom, something like that. And that's where genetics obviously is going to play a huge role in that, because if you're saying, you know, this FDA approved CRISPR drug, for instance, it's not just for any genetic disease, it's for sickle cell, right? Right now, that's what we've got. But as time goes on, I very much hope and expect we're going to have these CRISPR-based treatments for lots of different conditions. And genetics playing a role, that sickle cell is a genetic condition where we can do the genetic testing. Okay, we're diagnosing you. You have this. This is the specific genetic change of one letter is different, and that's how someone has that disorder. And so being able to use genetics to understand all that and group people that even if someone has the same disorder, they might have different genetic changes, mutations, variants that further classify them. I think cystic fibrosis is a good example of that, of a condition that a lot of people may have heard of mostly affecting the lungs, but also the GI system. And with that, you can have lots of different mutations. There's a really common one, but unlike sickle cell, where everybody has the same mutation, with other disorders, there can be different ones. So even within a certain condition, you can say, well, for people with cystic fibrosis, they're not all on the same medication, same regimen. It depends on their mutation and the symptoms they have from that. So it really is trying to get as specific as you can to target medicine and target the approaches for that.
Mm-hmm. And is that why you think they picked sickle cell as being one of the first to use CRISPR as a solution? Because there is just one, it's very definitive what needs to be changed.
Yes, I think it's very definitive. That is a very good point. I think the other thing is, because it's a blood disorder, it is easier, I say in quotes because it's all relative, but to be able to take someone's bone marrow out and then, I use this term, CRISPR it up, for lack of a better term. But it's one of those. So basically you're changing a gene and you're doing that in the person's cells, and then you're putting it back in their body. So we can do that. We've been doing bone marrow transplants for a long time. That's something that we've been doing in medicine. But to take the bone marrow from someone themselves, change that and put that back in, that's novel. That's really impressive. It's much harder to say for someone with, say, cystic fibrosis, we're going to take your lungs out, somehow change the genetics of those and put them back in.
Yeah.
That's a lot more complex, right? Like we can do taking someone's bone marrow out.
Okay. And because the body is, okay, so you put the cells back into the body, into the bone marrow, and I'm not you tell me if I'm getting this wrong, but then the body starts to replicate. Those cells replicate, and the other cells that had the original DNA that was defective, they sort of die away, and over time you have more of a predominance of the newer cells with the edited DNA sequence.
As I mentioned, I don't have sickle cell, I don't have cystic fibrosis, but so I can't speak to what that experience is like, but just from a scientific standpoint, you totally got it. With the bone marrow, if you're replacing that, then you're creating those new blood cells, and we're constantly, right now, the two of us are creating new red blood cells. And so that's constantly happening. So that's another reason why this worked out well for the CRISPR treatment, because we are constantly making new cells. Whereas we're not constantly replacing our lungs. Yes, we're creating new cells in our lungs, but we're not replacing our entire lungs every couple days.
And what are some, so the sickle cell is one type of condition, had very few variables, easier, still complicated, to use precision medicine for and genetics to make a correction. What are some other types of conditions that you think are similar to sickle cell in the fact that there's a definitive change that can be made without all these additional variables?
I think other ones that have to do with starting with the bone marrow. So things that are also potentially immune related, other types of blood disorders. So a very similar condition to sickle cell from a genetic standpoint is beta thalassemia. It actually is the same gene, HBB. So that makes sense that beta thalassemia being another one that we're like, okay, well, if we have sickle cell and we figured this one out, is that next? So I think conditions like that, I think it's going to be more complicated when it has to do with replacing cells elsewhere in the body, because it's just so much more involved. I think so many more complications can come up. I think we're going to figure it out over time, but I'm not like, oh, later this year, we're going to see this kind of thing. So, am I going to see it in my career? I hope so. I'm 29. So I hope, if I'm working for another 40 years, and maybe 50 years, I like what I do. That's a lot of time for things to happen.
Look what they did in just 12 years. And that's
exactly
fast for medicine.
I didn't think I'd be in my 20s seeing this. And we just made the cusp. This happened when I was 28. So, it was just made the cut. But I mean, how much am I going to see in the next 50 years in the field?
I think it's hard to predict, right? You just don't know what insights people are going to come up with that are going to just be a paradigm shift for specific treatment, right? I had another question for you related to semi-related to precision medicine, but this is around in vitro fertilization and how there's been some advances there, but there's an impact to the field of genetics. So what is going on here in that space?
Sure. So I mean, in vitro fertilization, IVF, it is something that's not new, right? It's been around. I think the first person that was born that was conceived via IVF, I don't know, are they 50, 60 now?
It was
something
in the 70s,
like
right?
that. Yeah, it was in
Late
the 70s. So I can't do math fast enough. But yeah, somewhere in there. And so we've had this technology, we've been using this technology for a long time. But something that is not new, but newer is looking at the genetics of an embryo and certain, not all of the genetics, but certain genetics of the embryo before implanting, and having that potentially help decision-making of which embryo am I implanting to hopefully develop into a pregnancy and then have a child. And so this is called PGT, PGS, pre-implantation genetic testing or screening. And there's a lot of different types. The most common one is just looking at the chromosomes. So, I have 46 chromosomes. I got 23 from my dad, 23 from my mom. I'm presuming you also have the same. I know because I've actually looked at my chromosomes, so that's why I'm using myself as an example yet again. Very cool. I used to be a student in a lab, and they're like, yeah, if you want to use your own blood and kind of look at your own chromosomes and print them out and put them in a frame. And I did the frame part. They didn't say that. I'm just such a nerd.
Yeah,
of course I did.
I totally would have done that.
You're not surprised at all. You're like, of course Kira has a frame of
I would have made a
t-shirt. Honestly, that should be my next step, Like Sticker Mule has those deals. Exactly. I'm like, yeah, I should get a $10 shirt with my chromosomes on it. And people say, oh, it's kind of like my headshot,
That's right.
Yeah, but so I know I've gotten 23 pairs of chromosomes from each, or I have 23 pairs of chromosomes, one set from dad, one set from mom. That's how 23andMe got their name. And so with the screening of the embryo, a lot of times we're looking at that. It's like, how many chromosomes are there? Are there any extra or missing that could lead to a miscarriage, that could lead to a genetic condition? So an example would be Down syndrome. People with Down syndrome have another copy of chromosome 21 than I do. So they have 3 copies. I have 2 copies. And so looking at that. So that we've been doing for a while. Another level to this is we can also get as specific as certain genes. So if someone, let's say, has a genetic change in a gene that predisposes them to cancer, then they can say, well, I don't want to pass that on to my kids. I want to do genetic screening of these embryos and say, all right, let me look at the ones that are negative that didn't inherit this genetic change. Let's go ahead and implant that. Now, this is all in a perfect world. You could do egg retrieval, create embryos. They could not make it. You could be doing multiple rounds. You could get to the point where you're doing this genetic testing or screening and they all come back positive, right? So in an ideal world, yes, you end up having lots of embryos to choose from and some that are negative for that condition. So there's this also whole nother level of, well, what if we start looking at multiple genes that have to do with different factors of looking at, this is where we start getting into like, well, now are we talking about designer babies? Like, can we start looking at hair color, eye color, height, intelligence, athletic ability, different things? I don't think we're there yet because height alone, hundreds of genes play a role in height. It's not just, oh, there's 10 different mutations or something or variants, right? So it's when we look at these more social aspects, I guess I would call them, of cosmetic, like how do we look, our intelligence. I mean, that's not really like that cosmetic aspect, but social, I guess, of just like, how is that impacting your life? Things that aren't directly impacting your health, like the rest of stuff. That's where it's kind of like, where are we going with this?
Yeah. And there's going to be some doctors in a country that doesn't have as strict regulations that's going to figure this out, and they're going to start doing it, and they'll, and that's going to create, I think that'll create a lot of controversy because I think part of the magic of, I don't have kids, but I think part of the magic of having kids
I don't either yet.
is that you don't know what you're going to get in a way.
Yep.
And that's, and leaving, I think is something to be said for leaving up the random selection up to nature ultimately is positive, right? Obviously, there's certain things that we don't want to pass on to certain generations, and things that can be fixed that are not useful in the species, but
like impact someone's health and daily life in a negative way, things like that. I think we would all say that, like childhood cancer or something, like nobody wants their child to be diagnosed with cancer. If there's any way to prevent that, the parent's going to do it, right? So there's certain things where I think most people would agree with us and saying like, okay, that's something that, if we can screen that out, great. But then there is that gray area of like, is height something that, it is advantageous to be taller. Like there have been many studies that show people that are taller end up making more money. They end up like being more successful in a lot of ways. They, so there's just, you could look at the athletic side of like, if you're taller, you're probably going to be a better basketball player than if you're shorter. Not necessarily, right? There's a lot of people that are on the shorter side that are really, really awesome and are fantastic basketball players. I went to UConn, so I kind of have to say that our women's team is insanely amazing. But there is that gray area of just how does that work? And how we view that, and people are going to view it differently. And I think a lot of companies are going to be saying, oh, we offer this, we look at this. But if we're taking this height as an example again, if they're looking at a handful of genes that impact height, you're just scratching the surface if there's hundreds of genes we've identified that play a role. So is that disingenuous and more misleading to say to people, oh yeah, we look to see and look to see the height of what your kid would be. And it's like, all right, well, if you're looking 5 out of hundreds of genes, what is that?
Yeah.
So
how do you really know? It's not.
Yeah.
There's too many variables there. Mm-hmm. And that leads to my next question, which is related. There's, with genetic testing, how do you talk about these things to help navigate these ethical questions and potential consequences with your guests?
I think it's asking a lot of questions, honestly, of just not being like, oh, okay, that's how that works. And diving in deeper and saying, just as we've been doing, Lisa Ann, of just exploring like, okay, well, if we can do this, should we do this? And what line should be drawn? Who's going to draw the line and enforce that's where the line is? Like, I think all these topics come up, and I think it's important to hear from a lot of different viewpoints, especially when we're talking about certain conditions and groups of conditions and saying, well, we can be either correcting these conditions, even using that term like correcting and just the negative connotations that go with certain things, but including people that are from those communities in these conversations. I think that is so important. We can't just be sitting around as scientists talking about this. We need to include people that are already living this truth and experiencing these different paths of life and being able to include them in conversations, because the patient advocacy side is not to be put to the sidelines. I think that's really, really important. But it's tough to be including everybody in the conversations, but we need to.
Mm-hmm. Yeah. It's over here in my world, with the women's organization I run, it's like we talk about like it's a little pale and male over here. Like,
yeah, I like that term, pale and male. Oh boy. That is too catchy. I'm gonna have to credit you when I say that in the future.
Please do. I came up with that a few years ago. I can't take the credit for Manels, which is another one that they talk about. But so speaking of your guests, what are some of your favorite episodes? Like if someone was going to go, and we're going to put a link to the show in our show notes. So if someone's going to go check out DNA Today, what would be some of the episodes you would recommend they listen to and why?
Yeah. So, I mean, I guess I'm thinking, I'm like, people that listen to your show, they're just kind of curious about like how the world works in the future and all of that. I think any episodes related to CRISPR, as we were talking about, if that stuff interests you, I think check that out. The episode that I mentioned, I should have said her name. The first person to be cured by sickle cell by this drug, her name is Victoria Gray, and she is amazing. And she is a spokesperson and has inspired a lot of other people to get the treatment as well. So that we actually ended up having 2 episodes with her. So it's episodes 288 and 289. But yeah, we've done so many fun episodes. I think I want to go all the way back to the episode I did where my friends and I, after finals were over, I was in grad school. We're like, all right, we're done for the year, the academic year, the finals. We're like, let's watch Gattaca. Have you ever seen Gattaca, Lisanne?
Yes, I have, of course. Long ago, though.
That is the right answer. So Gattaca came out. This fall will be, how old am I? It's 27 years.
Dang.
27 years ago, because it was the same year my brother was born. So that also helps me figure that out. I'm not good at math. And so we watched it. What year? We watched this in 2019. And then we're like, all right, let's turn the mic on. Let's talk about it. And it was such a fun episode. We basically talked about how in those years since it came out in 1997, when it was all science fiction, what is now science? Take off the fiction part. And that is just so interesting. Every couple of years I watch Gattaca, and every time I watch it, there is more in the movie that is just, that's how we do it. It may not be precisely how we do it, but they got the concept down. And it's just remarkable. It's also, even if you're not a genetics science nerd like me, it's also just a phenomenal movie. I mean, Uma Thurman, Ethan Hawke, like, who's the British guy? Jude Law, like, a phenomenal cast. I mean, it is such a good movie. One of my favorites, obviously, with how enthusiastic I am right now. But I mean, it's just remarkable. And it kind of goes back to our conversation of looking at a world where some people are naturally conceived, and we're like, as you were saying, kind of like it's the randomness of what your kid ends up being the excitement part. But then in this world that Gattaca is set in, futuristic, some people are conceived via kind of IVF with this. And it's interesting because in Gattaca, they're not genetically editing, if I'm remembering right. They're not genetically editing any of the embryos. They're just picking the best in front of them and saying, well, this one is going to have the best, all those factors I mentioned. So they're not editing like we were talking about with CRISPR, where you're actually changing genetics. They're just like, let's just pick of the best that your sperm and egg made. And just all the repercussions of people that were conceived that way, that are, you know, the haves versus the have-nots of being naturally conceived, and all of the different ethical issues that come up and the technology that comes up. And it's just, it's a wicked awesome movie to kind of dive into.
I like that. We'll definitely put a link to the show notes for that one.
That's episode 110. Yes.
I think I feel like I got to go watch Gattaca first and then listen to your show.
And it's just one of those movies that's really fun and starts a lot of interesting conversations of like, should we be doing this? Is this where we're headed? Are we going to be living in a world like this? Because there are aspects where it's like, yeah, that is where we're headed, because in 97, was science fiction. And now there are aspects we're doing today or that we have the ability to do today.
Yeah. And I think, it's a question of, in 10 years, are we all going to be living in the metaverse anyway? So it doesn't matter what you look like, because you can pick your avatar and you can be as tall or beautiful or ugly or whatever that you want, right?
Yeah.
You could be the metaverse,
AI, like there's so many other things that we're going to see it all combining. I've done also episodes about AI in genomics and like how are we using that? How does that work? What do we need to be worried about?
What are they using it for right now?
I mean, it's so much in its infancy, I feel like, but some things are that I've talked with some researchers and scientists about that are actually in the lab, using it to, as they're doing genetic testing, and where we each have so many different variants, changes between us. They're not necessarily detrimental, but having AI help sort through, okay, these changes are more likely to be causing the disease that this person has. So maybe focus on these first, look into these and prioritizing. And maybe you'll hit that disease-causing variant before the ones that are just like, it's human diversity. Everybody's a little different. That's what makes the human race really awesome.
Okay, we'll put a link for that one in the show notes as well.
Yeah.
So looking to the future, I know we've talked about CRISPR and other things that have been developing and will continue to develop into the future. But what's your prediction in terms of how we're going to continue to evolve our genetics, the work in genetics that healthcare industry is doing right now, scientists?
I think we're going to see that it's going to become the norm for people to have their entire genome sequenced, called a whole genome sequence. So all of their genetic information spelled out, analyzed, and to be able to refer back to that over the course of their life to help with managing health conditions and different aspects. I think we're going to see countries other than the US do this first and doing it in the newborn stage. So we have something wonderful called newborn screening we've had for decades and decades and decades. It started with a condition called PKU, and we've added a lot more conditions. In the United States, every state is different with how many conditions are on that. There is a core list that everybody's screened for, but then every state is a little different of adding on more. But I think instead of just looking at those certain conditions, in addition to that, in addition to that, having babies have their whole genome sequenced and being able to refer back to that. And I think we're going to see that in other countries that have universal healthcare because our healthcare system is so big. We have so many people. I don't see how we're going to be the first to do it, but I think other countries will. And just how much that's going to impact people of being able to refer back to that throughout their life and having a heads up of certain things as soon as a baby's born or a few days or weeks after. I think that's really going to shift. And there's a lot of other people in the field. These are not just my ideas, but what I've learned from other people like Dr. Stephen Kingsmore at Rady Children's and a lot of other leaders in the field that have kind of been expressing, those kind of future predictions.
Mm-hmm. I think having that information is very useful. There's always, I can also see like some social jokes coming from that. It's like, I'm sorry, that's not in my genome. I can't. Yeah. I'm not going to do that. I'm not predisposed to that.
I won't take a coffee. I actually, I'm caffeine intolerant. Like that doesn't. I already know that. So I've never even tried coffee because I know in my genome, it says that I'm very much affected by caffeine and I'm more likely to be addicted to it. And I can say yes, that's true. So. It's like how much of it is going to be weird little social things like that too, not just the big health impacts. Yeah.
Yeah. I did 23andMe and it told me that I metabolize caffeine rapidly. I have
yes, that's what I meant to say. You said it more eloquently than I did. Yes.
And then I was like, And I looked back at my family. My brother is a total coffee freak, does the pour over with the special beans and the timer and the weight and everything. He's got my mom doing that now. Mm-hmm. My dad probably has 4 cups of coffee in the morning.
I'm cranking it for 4 minutes. Yeah.
And I'm like, is the fact that this entire family loves coffee, the fact that we all have this gene that allows us to metabolize it really fast, so you get that jolt of energy and clarity. It's so clear and fast. You're like, oh yeah, coffee, you need more.
Right. Of course, it's addictive, right? Yeah. Whereas other people that coffee doesn't really affect them as much, they're like, I'm not as into it, right? Like they're not a coffee fanatic. They're not Lorelai Gilmore or something, right? Where they need the IV of the coffee. But yeah, it's just all of these little things like, oh, are you a morning person? Like I am not. Like
I'm not either.
Yeah. And the genetic variants that I've looked at are consistent with that. But then again, on the other end, I've seen things like, oh, I am less susceptible to be anemic. I'm like, no, I'm actually really anemic. Like when I go to donate blood, most of the time I'm like, nah, sorry, you're not good enough today. I'm like, all right, sure. I'm not, my blood doesn't have enough iron for you. But yeah, so there's also some things that it's like, because sometimes they're only looking at one variant, they're not taking into account all the other variants that could be playing a role as well. So, sometimes, it's not the full picture sometimes.
Yeah. So what's something we should look out for in the future as things are developing, as Earthlings here who have
Yes.
the opportunity to elect certain people to make certain decisions for us or influence certain healthcare systems? What's your advice for average people as we're navigating this new future of genetics?
Yeah, I think it's tough in terms of like electing people because, I think most people in politics are not well versed in genetics and how that can affect health and everything. But hopefully they're smart enough to know who to hire in those positions to help them with that. But I think just keeping your eye on the topics that we've mentioned, like CRISPR, like how AI is going to intersect with this and so many other areas of life, right? With AI, I think really just becoming the new normal. But I think for people personally of looking at if you do have a health condition or health conditions in your family, keeping an eye on how genetics is, we're learning more and researching more in that area and seeing if there's any developments there of like, now we have genetic testing for that. You can see if you actually are predisposed to something, or we have genetic testing to see if we can diagnose you with something and then have a certain medication, or a certain prevention screening plan. So I think that's things to be mindful of and, be asking your healthcare providers, hey, I've got this going on. Is there any updates in genetics where I could be doing testing or anything different that, things are changing so rapidly? I tell patients every 6 months, be checking in. So really often.
Earthlings. What a fascinating future we have in store where medical treatments are tuned precisely to the people they're meant to treat. And we can down select for genetic traits that could cause negative effects for people. I mean, of course, what does the word negative actually mean? It's a bit subjective. And, where do you draw the line in terms of what's medically necessary and ethical and what isn't? So I think it's going to be really interesting to watch all of these developments and ethical questions play out over the next decades. And I'm sure Kira is going to keep her mind tuned and focused to these developments. So be sure to tune in to DNA Today to learn from her and her guests wherever you get your podcasts. Our faith in humanity is restored this week by Ripi Yanur Fajar and his 4 friends. On an Indonesian island, they encountered a big cat roaming a community plantation. And immediately afterwards, Ripi, who happens to be a local conservationist, contacted researchers in his country to tell them that he thought they had either seen a Javan leopard, which is critically endangered, or a Javan tiger, which is a subspecies believed to have gone extinct in the 1980s, although it was only officially declared extinct in 2008. So a local researcher, Kali Raksha Siwu, joined Ripi, and they went back to the location of the sighting 10 days later, and they found a single strand of hair that was caught on the fence that the animal had jumped over. They mobilized some geneticists in the country to analyze this single strand of hair, and they compared it with known samples of other tiger subspecies like the Sumatran tiger and a nearly century-old Javan tiger pelt that was kept in a museum. And laboratory results showed that the hair sample was 97.8% similar to the Javan tiger. Their work was peer-reviewed and published in the journal Oryx and suggests that this long-extinct Javan tiger may somehow, remarkably, still be prowling one of the most densely populated islands on this beautiful blue-green space flower that we call home.